11. Find dy dx if f of x is equal to x to the e plus 7 to the x squared. So I would like to find the derivative again. This one probably looks a little bit trickier. The biggest thing on this one, x to the e is just some sort of constant. So this is going to be treated the same thing that I would do e to the x if I did x cubed. Remember, if I took the derivative of x cubed, it would just be 3x squared. We're just bringing the power down and reducing the power by 1. So when I take the derivative of that part, I'm just going to bump the e out front, and then x, and decreasing my power by 1 would just be e minus 1. So that's the derivative of that first part. Okay, the second part, please remember if I have a constant base to a power, we've got 7 to the u, the derivative of that is going to be the same thing, it's just its own derivative. But then remember, we do have to multiply by the natural log of that base. So it's going to be times the natural log of the base, and then also, of course, times the derivative of the exponent. So let's see if we can do this. All right, so it's its own derivative, so 7 to the x squared, and then times natural log of 7 times the derivative of that x squared, which is 2x. Okay, when I look at that, it doesn't look like there's anything I can factor out. So really, that's my answer, and I really don't think there's a good way to clean it up at all, so I'm just going to go with that. All right, number 12. Y equals log base 5 of 3x times the square root of 6x minus 1. All right, before I take, first of all, I do see a log in this problem, so I know that I'm going to be using this formula right here. Just the same thing as if I have ln, it's just du over u, so it's going to be du over u, but I do have to multiply by ln a, if you remember that formula. So that's what the formula that I'm going to use. Before I actually try to use this, though, I'm going to separate it into two parts just to make this problem easier. So this will be log base 5 3x plus log base 5 of the square root of 6x minus 1. Okay, and then I'm actually going to go a step farther because the square root is a 1/2 power, which I can bump out front. So my new problem is going to be log base 5 of 3x plus 1/2 log base 5 of 6x minus 1. Okay, now when I go to take the derivative, that formula will be a lot easier. Okay, so if I have a log, it's du over u times the natural log of a. So du would be 3 over u, which would be 3x times the natural log of 5, because that's the base is 5, and then plus 1/2. Then again, du would be 6 over u, 6x minus 1, times the natural log of the base, which again is 5. Okay, I do notice, let's see, the 3's cancel, and the 2 and the 6 would cancel and make 3. And then I also notice that they both have a natural log of 5, so I'm going to factor out 1 over natural log of 5 and just see what we have left here. So if I factored out 1 over natural log of 5, I'd only be left with 1 over x in that first part, and then I'd be left with 3 over 6x minus 1 in that second part. And then I think I'd call that good. Okay, problem 13, evaluate x squared times 4 to the x cubed dx. The hint that I have offered on this one is if you have a constant base, you will always let u be the exponent. So we are going to let u equals x cubed. You don't care about anything else that's happening in the problem. Okay, the derivative of x cubed is 3x squared dx. Notice we have x squared, we're just missing a 3. So to undo that, I'll put a 1/3 on the outside. So I'm going to have 1/3. I've done nothing with the 4, so the 4 is still there. And then my u is x cubed. And then everything else in that problem we turned into du. So we know that the integral of a to the u is equal to, it's its own integral, but then we do have to divide by ln a. So when I do this problem, it's going to be 4 to the u, which is 4 to the x cubed, over the natural log of the base, so natural log of 4. So cleaning that up a little bit, I'd rewrite it as 4 to the x cubed over 3 natural log of 4 plus c.